Hello, hello. Today we're talking about zeros and multiplicities of polynomial functions. So a zero is where a point crosses the x-axis. So those are also known as x-intercepts. Remember that this is a point. So it's a number, comma, zero. And it comes from setting those factors equal to zero. Multiplicity talks about how many times a factor shows up. So if you have a factor that has an even number of repetitions, so x plus 2 to the second power, that's an even multiplicity. It means that it touches the graph, it just kisses the graph. And if you have an odd multiplicity, so a factor that only shows up one time or 3 times, then it's going to pass through the graph. Let's take a look at this function, which is in factored form. This is best explained with an example. So we're going to determine the degree, the end behavior, and we're going to sketch the graph of this polynomial function. So first we're going to look at the degree. We want to look at each one of these factors and think if I were to multiply those all together, I would get x times x times x in that first term, which would be degree 3, x to the third power. We've already talked about end behavior. So we know that something that is degree 3, that has a leading coefficient that is positive, is going to go down on the left side of the graph and up on the right side of the graph. You can always check this in your calculator, but we do have a rule that states if we have an odd degree and a positive leading coefficient, that as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. Now, in order to sketch the graph, I want to find the zeros of this function. So luckily, this has been given to us in factored form. So all I need to do here is set each one of those factors equal to 0. As we're solving these 3 equations, we're going to find that x is equal to -1, positive 2, and positive 4. Those are my 3 x-intercepts. So I could write those as points, -1, 0, 2, 0, and 4, 0. These all have multiplicity 1 because each factor only shows up one time. So on a graph, we can plot all 3 of those points at -1, 2, and 4. When we plot those points on there, we know that this has an odd multiplicity. So we know that those points are going to pass through the graph when we connect them together. We know that the end behavior on the left side of the graph points down, and we know that the end behavior on the right side of the graph points up. So we just have to kind of plot those points and connect the dots based on the information that we have. Now, if you have a graphing calculator, we can plug these into the graphing calculator and we can get a better picture of this. I should be able to see that this graph resembles what I predicted the graph was going to look like. So the sketch of my graph is a prediction. It's not exact, it's not beautiful, it's just a sketch. So here we're looking at another factored form of a polynomial function. Now we're trying to think what the degree would be if we multiplied all of those things together. So we would have x times x to the third, which would give us x to the fifth. So this is degree 5. We know that the leading coefficient here is negative, so we can predict the end behavior. We know that for an odd degree function with a negative leading coefficient, as x approaches negative infinity, y approaches positive infinity, which means the graph is just going to go up on the left side. And then we know that as x approaches positive infinity, y approaches negative infinity, or the graph goes down on the right-hand side. Now we can go ahead and find those zeros, or those x-intercepts. So I can set each one of those factors equal to 0, and then I can solve for my x-intercepts. Now I have enough information that I can sketch a graph of this. So first I'm going to go ahead and scale my graph so that I can put those x-intercepts on here. So I have that x-intercept at -3, -2, and then +3. The end behavior tells me that this goes up on the left and down on the right. Each one of these has an odd multiplicity, even though that x minus 3 shows up 3 times, it's got multiplicity 3, these each have odd multiplicity. Both of those first ones have multiplicity 1, and the third one has multiplicity 3. So all of these pass through the graph. Now, this graph probably doesn't look like this. This graph looks super funky. So I'm going to go ahead and plug this into my graphing calculator to see what it looks like. I like how the TI calculator draws this in real time so that you can see that it comes from the top on the left side and then goes to the bottom on the right side. So even though we'd have to zoom out a little bit more to kind of get a better picture of what this looks like, we can at least tell that the left side goes up and the right side goes down. Okay, one last example before I let you do one by yourself. For this one, when I count up all of those x's, I have 1, 2, 3, 4 x's. So this is degree 4. Because this is degree 4, I know that we have same end behavior. And because the leading coefficient is negative, I know that both sides of the graph point down. So I just need to translate that into math. So as x approaches negative infinity, y approaches negative infinity because of that negative leading coefficient and because this is an even degree. As x approaches positive infinity, y also approaches negative infinity. That means that on the left side and the right side, both go down. Okay, so we want to set each one of our factors equal to 0. So that negative x is a factor. We're going to set that negative x equal to 0, the x plus 5 equals 0, and the x plus 3 equals 0, and solve. So we find an x-intercept at 0, -5, and -3. Now we need to take a look at the multiplicities. So the only one that has an even multiplicity here is x plus 5. We know this because x plus 5 has an exponent of 2. Now, negative x and x plus 3 both have multiplicity 1 because they only show up one time. They have no exponent that you can see, so you assume that it's 1. So remember that an odd multiplicity tells me that the graph passes through the x-axis, and an even multiplicity tells me that the graph touches or just kisses the graph at the x-axis. So now we're going to look at this graph, and I'm going to plot each one of those x-intercepts on here. So x equals 0, x equals -3, and then x equals -5. Now I want to pay really close attention to this end behavior. Both of these arrows need to point down towards negative infinity. So I'll put my arrows first. Then I want to pay attention to that multiplicity. So at -5, the graph just kisses the x-axis. So it's just going to kiss it, and then it's going to leave. It's got to come back around and pass through -3. So I'm going to make that graph turn around and pass through -3. And then I've got to make it turn around again to pass through 0. When I first tried to type this into my graphing calculator, it yelled at me. It said this doesn't exist or something. So I had to go back through and type out -x, then a multiplication symbol, then x plus 5 in parentheses squared with another multiplication symbol, and then x plus 3 in parentheses. Then it finally allowed me to graph this. You have to look really close and kind of watch this as it graphs, but you can see that it's heading down on the right. That extra bold piece on that y-axis is showing me that that graph is heading down on the right side. So you kind of have to watch it graph so that you can see that better, or you can look at the t-table. So I can see here on the t-table that after that x-intercept at 0, 0, those y values are heading down towards negative infinity. Okay, so it's your turn. I want you to try everything. I want you to count up those x's to find the degree. I want you to pay attention to the leading coefficient to determine that end behavior with the degree. And then I want you to find the zeros of that function, try to graph it, pause the video, come back when you're done. Okay, so this one is degree 5 because we have 5 x's. The end behavior tells us that we have arrows going down on the left and up on the right. And then I'm going to go ahead and put these x-intercepts on there at 0, 1, and -2. I'm going to start from the left side going down and end on the right side going up. So at -2, I know that the graph passes through because it has multiplicity 1. So I'm going to let that graph pass through -2. At 0, this graph just touches or kisses the graph. So it's got to come back up, and then it's got to kiss and touch the graph at 1 as well. So it makes just like a little bump there, hits the 1 and comes back up. I'm obviously going to check to see what this looks like in my calculator. So notice as I'm typing this, I'm putting multiplication symbols in between those sets of factors. And I'm just doing that so that I can make sure my calculator graphs the correct graph that I want it to graph. I slowed this down quite a bit so that you can watch it when it hits the 0 right here. It comes up really slightly, hits the 1, and then goes straight up. All right, guys, gals, and everything in between, thanks for coming. See you next time.